All right, let's start part 2 of this. This is chapter 2. We did linear equations, and later we did transformations. So, number 19, determine if the following are parallel and perpendicular. These aren't too bad as long as you remember parallel are the same slope, same m, and perpendicular are the opposite reciprocal. Now, that's all fine and dandy unless you don't remember what opposite reciprocal means. So opposite reciprocal, opposite refers to positive and negative. So if it's a positive, change it to a negative. If it's a negative, change it to a positive. Reciprocal is flipping your sign. So if it's x over y, you need to flip it to y over x. That's all that means, flipping that fraction. So the ones that hopefully are easy are the ones that are in slope-intercept form, so I can already see my slope. That's the same slope, so those are parallel. So this one slope is negative 3 over 2. This slope is just 3, so that means that is 3 over 1. So the opposite reciprocal, it's positive, so the opposite would be negative. The reciprocal would be 1 over 3, which is what we have down here, so that is perpendicular. Now this one is a little bit more of a struggle because you have to find your slope. Now there's two ways to do this. You could put them in slope-intercept form, or you could remember from a formula sheet. If they are in standard form, you can use this negative a over b. So that's what we're going to use for this one. So the a's are first, the b's are number second. So for my first one, negative a over b is negative 4 over 1. So that's going to be negative 4. So that's my first slope. My second slope, the second one, is negative 8 over 2. That reduces down to negative 4. So those are both the same, so that is parallel. And the last one, we have 2/3 and negative 3 over 2. That one hopefully is a little bit easier. It's reciprocal because we have 2 over 3 and 3 over 2, and it's the opposite because this is a positive, this one's a negative. Remember, it does not matter if the negative is with the numerator. It could be with the denominator, or it could be out front. All those fractions mean exactly the same thing, every single one of those. The only thing that's different is if there's a negative in the numerator and the denominator, and that's a positive. Other than that, though, it doesn't matter numerator, denominator, or out front. So that's perpendicular. So graph the following lines. Slope-intercept hopefully is pretty easy by now. So we have 3, and then my slope is negative 5 over 2. Remember, and I said it's the same thing if the negative's out front. I think with graphing purposes, it's easier to put up with the numerator, but like I said, it's the same thing. I didn't change anything. So that means we go down 5, 1, 2, 3, 4, 5, then over 1, 2. We have our second point. Remember, you could do the opposite. Instead of down and to the right, you could go up and to the left. 1, 2, 3, 4, 5, and then to the left, 2. You don't have to, but it's an option. And that gives you this line. Now this one, again, you can either put it in slope-intercept form or use the cover-up method or the eye patch method. So we could cover that up to find our x-intercept, divide both sides by 2. So our x-intercept is 2. Then we cover up the other one. Divide by 7. Our y-intercept. I messed that up, didn't I? Sorry. This is why you shouldn't wait till 11:51 down here to do this stuff. Okay, to try this again. Divide by 2, divide by 2. Our x-intercept is 7, not 2. So our x-intercept is way over here. Hopefully you guys were yelling at me, or at least mentally yelling at me. The next one, cover this up, divide by 7, divide by 7. Our y-intercept is 2, so that is our graph. Whoops. And this is a perfect example. Again, make sure you put your points on there, because even the one that I just drew, I totally missed my points, but I can see the points on there. I'll give you credit for that, for sure. The other way you can do this is you could solve this, put it in slope-intercept form. So you'd subtract 2x from both sides. You'd end up with 7y is equal to negative 2x plus 14. Divide everything by 7. You'd end up with y is equal to negative 2 over 7x plus 2. So that's my y-intercept is the 2 here. That 2 right here. And then you go down 2 over 7, which lands you at this point. One thing I will say, I should have said it with part A, but make sure you know slope-intercept form. A lot of people are still missing this because this is your y-intercept, not your x-intercept. So this 3 goes on this axis. When we found our y-intercept up here to be 2, or when we did the cover-up method and found 2, that is our y-axis. It goes on our y-intercept. Or vice versa. Our y-intercept goes on our y-axis. Again, there's a ton of people, I mean not a ton, but there's surprisingly the amount of people that still are saying, oh, this one's positive 3, and they put it right here. No, that's the x-intercept. That's not going to get you points. X is equal to 4. Remember, if it's y is equal to a number, that is a horizontal line. X is equal to number is a vertical line, so that is this line. And same thing with this last one, where if you want to, cover up method, divide both sides by 3. I apologize, this goes off your graph a little bit, but your x-intercept is over here at 8, just one step off, so it's not the end of the world. Then your y-intercept divided by -4 is -6. Oh, -6. And so that is your graph. Or again, you could put that in slope-intercept form. So subtract the 3 from both sides. So you get -4y is equal to -3x plus 24. Divide everything by -4. Y is equal to -3 over -4 is positive 3 over 4. 24 divided by -4 is -6. Either one will totally work. I personally like to put them in slope-intercept form, but that's just me. I was going to check the answers to that, make sure I didn't mess that up either. Okay. Cool. All right, the next ones we have inequalities. Again, this is your your y-intercept. So your y-intercept is on your y-axis, the up and down axis. I go up 2 over 1, 2, 3. This is a dotted line because there's not the line under it. And then I had a lot of people asking me this recently, which is fine, but make sure you remember it's not difficult. Which way to shade? If y is less than, you shade below. If y is greater than, you shade above. You don't have to make it more complicated than that. The next one, the y-intercept is 1. The slope is 2, so 2 over 1. So up 2 over 1, 2 over 1. It's a solid line this time. Y is greater than, again, greater than is above. Less than is below. Now this is the exact reason. If you find your x and y intercepts for this one, that's good, but it's hard to find where to shade for this one if you do it that way. So I just recommend putting it in slope-intercept form. I think that's the easiest. So subtract 2x from both sides. I'll show you why it's hard the other way here on this next step. Because on this next step, we have to divide everything by -3. Well, since we divide by negative, you have to flip your sign. So y is greater than 2 over 3x minus 4. Sorry, I ran out of room. So -4 is down here, and I go up 2 over 1, 2, 3. It's dotted. And now, since the y is by itself, now y is greater than, so we know to shade above. You have to have the y by itself before you can do that trick. That's why you can't do it up here. And the reason we would have missed it is because we had to flip the sign, because we had to divide by a -3. If you do use the x and y intercept to do that, the eye patch method, that's fine. You'll just have to sub in a point that's not on your line. And if it's true, that's what side you shade. If it's false, you shade the other side. If you're curious about that method, because I just said it very quickly, let me know and I can talk to you more about that. But I don't recommend that method and I don't want to confuse you guys. So if you do want more information on that, I'll definitely tell you. It'll be a great time. Write the equation of the line with the given slope-intercept form. Okay, so don't make this harder than it is. We found the y-intercept. The slope, it goes through this point, so I go down 2 over 1, 2, 3. So we know my slope, we know my y-intercept, so it's just y is equal to -2 over 3x minus 2. A lot of people still struggle with that, and again, it all comes down to finding your x and y-intercept. Or sorry, your y-intercept and your slope. Okay, 23. Find the equation of a line in slope-intercept form that has a slope of 1/3 and a y-intercept of 7. Again, please don't be missing these because slope-intercept form, if you don't know what that is, they're on your formula sheet. And we have, let me this up a little bit. You have your slope and your y-intercept. That's all you need for that. Well, that's what they give you. So y is equal to, your slope is 1/3. Make sure you don't forget the x. Your y-intercept is +7. Don't make that harder than it has to be. Find the slope of a line that passes through -6, 5, 3, -11. Again, use the formula sheet. Use this equation. This is my x1 and y1. This is my x2 and y2. So I have -11 y2 minus y1, -11 minus 5 over over 3 minus -6. Honestly, if I were you, I would use a calculator. Type in -11 minus 5, it's -16. Type in 3 minus -6, minus negatives plus, so that's 9. Again, I would just use a calculator. And then I don't know if that can be reduced or not, so I'm going to use my calculator for that one for sure. 16 over 9. Oops. Nope, that can't be reduced at all. That took way longer than I thought. Don't tell Mr. Ulrich. He'll be disappointed because he taught me how to do that stuff. But I like to double check in a calculator still, just to make sure, so I don't make any silly mistakes like you guys have seen me do bunches of times. Which is another one I missed in the answer key, that's funny, speaking of mistakes, I missed out on the answer key. On the answer key, I put 5 again right here for 3 for whatever reason. So it's -16 over 11 on the answer key. That's wrong. I don't know why I put 5 there. I mean, I know why I put it, because I was going way too quickly, because I was trying to get this out to you guys as soon as I could. But it should be -11 minus 5 on the numerator, and then definitely 3 minus -6 in the denominator. So I will change that on the answer key. Should probably start jotting these down. So, moving on to number 25, find the equation of the line and slope-intercept form that passes through those two ordered pairs. So this one's going to take a little bit of time because there's several different ways to do this. There's the way I like to do it that I've been teaching you, but there's a way that some of you guys know from before. Either way you do it, the first thing you have to do is find your slope. So do it the same way we just did. 8 minus 4 over 4 minus 1. So 8 minus 4 is 4. 4 minus 1 is 3. So it should be 3 over 4. Or sorry, 4 over 3. Looks like I was able to get that one right. So I'm going to write that up here just to save myself some room. So the way I taught you guys to do this now is to use point slope form. So point slope form is over here on our formula sheet. I like that way best. And there's going to be times you have to use that. It's not that I'm going to make you. It's just times that, like this one, it gives you point slope form, and you have to put it in standard form. So I don't require you to use point slope form, but I'm giving that to you and telling you to solve it. So it's up to you. So that is y minus y1. I'm going to use my first point. Doesn't matter which one. So y minus y1 is 4 is equal to my slope times x minus x1 is 1. Now from here we have to solve this and get it in slope-intercept form. So distribute your denominator, go to the left, your numerator goes to the right. So you have 3y minus 12 is equal to 4x minus 4. Now we need to get the y by itself because that's slope-intercept form. So at 12, we end up with 3y is equal to 4x plus 8. Divide by 3, divide by 3, divide by 3. We end up with y is equal to 4 over 3x plus 8 over 3. Weird fraction for your y-intercept, that's fine. That's why it's going to be a little bit harder using the other way. So using point slope form, you can do it that way, or I'm not going to do this I'm not going to take a ton of time on this because you will get the same answer. But instead of doing that ordered pair, you could use the other one with the 4 and the 8. So you could have used y minus 8, x minus 4, distribute just like before. That's 3y minus 24 is equal to 4x minus 16. Add the 24 to both sides. We get negative 16 plus 24 is 8. So we have 3y is equal to 4x plus 8. Divide everything by 3, you get the same answer. So it doesn't matter which ordered pair you use. Now the other way some of you guys did this, and this is the reason I don't like this way, it's really nice, or it works better when you don't have a y-intercept, or sorry, it works better when your y-intercept is a whole number, not a fraction, but I still like point slope better anyways. I just don't like to work with fractions. But some people use slope-intercept form. And what they did was they needed their y-intercept. I know the slope, so to find my y-intercept, but they were able to use one of these, and it didn't matter which one. So y is 4, so they plug that in for y. My slope is 4 over 3. And then my x is 1. And then we're solving for b. So that's not too bad so far. And 4 over 3 times 1, honestly, that's not even that bad. Sometimes it's a lot worse. But then here's the tricky part. I have to subtract 4 over 3 from both sides. Now again, the only saving grace really is that you can do fractions on your calculator. So if you want to do it this way, you can still plug in 4 minus 4 over 3. That'll be fine. It'll give you it'll give you positive 8 over 3. But I don't like that way. So once you do it this way, it does give you positive 8 over 3 for your y-intercept, and then you plug it in, y is equal to 4 over 3x plus 8 over 3. But I would use point slope form if I were you. Moving on to the next one. Find the equation of a line in point slope form that has a slope of negative 3 over 4 and goes through negative 5, 8. Now this is really nice with point slope form because it gives you a point, it gives you a slope. So you have y minus your y value is equal to your slope, negative 3 over 4, times x minus your x value. The only thing I ask is if you have minus a negative, change that to a plus, and then rewrite that to clean that up. Negative 3 over 4, x plus 5. Next one's in point slope form, but it's kind of nice because the slope is a whole number. So if you want to put it over 1 and then distribute to the bottom and to the top, you totally can. But you don't have to, because multiplying by 1 doesn't do anything. So really, all you have to do, since it's not a fraction, distribute your 4. So we have y plus 6 is equal to 4x minus 8. Now remember, we're going to standard form, so I want the x and the y on the same side, all the constants on the other side. So y is equal to 4x minus 14. Last step, get the x on the other side. So we have negative 4x plus y is equal to negative 14. Now here's a problem. You cannot have a negative with your x, so it's got to be positive 4x. Now if I switch that sign, I have to switch every other sign. Negative y is equal to positive 14. So really, I multiplied everything by negative 1, but I think it's almost easier to remember if you subtract, or if you change the sign for one number, you have to change it for all the numbers. Changes from point form to, okay, so this one's the same thing. Let me check, did I do that? I feel like I didn't do that. Oh, I did that. Cool. So same thing, we just have a fraction. So distribute to the left and to the right, just like we did before. So that's 3y minus 12 is equal to negative 2x minus 18. Then solve for y. Get the y by itself, so we add 12. 3y is equal to negative 2x minus 6. So again, you're going to have to know how to solve for y anyways in this way. So on this one over here that I did, I would totally do point slope form because you're already going to have to know that for a question like this. So I guess maybe I am making you know how to do it. I guess I should say I'm not going to say you have to use it on a problem like this, but I will give you point slope form like this until you put it in standard form. So I guess take that with whatever you want to call it. Negative 6 over 3 is negative 2. Oh, jeez. So, glad I checked. Again, this is standard form. This is a slope-intercept form. So the good news is, all I got to do is go back a little bit to this step. So I distributed to the left and to the right. I got my 12, I added my 12 to both sides right here. And so now I want to get the x on the other side, so I add 2x, and that gives me 2x plus 3y is equal to negative 6. Glad I checked that. Don't go too quickly and don't take your final exam at 12:07 a.m. Change this equation from point-slope form to slope-intercepts. Now we're going. This is what I was thinking. So distribute just like normal. 4y plus 20 is equal to 3x minus 36. And get the y by itself. So subtract the 20. 4y is equal to 3x minus 56. Divide everything by 4. You get y is equal to 3 over 4x. Then 56 over 4, I bet reduces nicely, is 14. So minus 14. Slope-intercept form to standard form, the biggest thing is you can have fractions. So the first thing, you don't have to do this first. You could add 1/2 x, but I don't like to deal with fractions. So I'm going to multiply everything by 2 first. So you have 2y is equal to, with your fraction, 2's cancel. That was the whole idea. So we have negative 1x plus 10. Now put it in standard form. We just have to get the y, the x on the other side. Again, I apologize about my dishwasher. It's Samsung, so listen to that puppy purr. X plus 2y is equal to 10. So again, another one I made a slight mistake on the answer key. I forgot to multiply the 2 times the 5, so I have a 5 right here instead of a 10. This is correct, not my answer key. Again, I'll change it on Monday and I'll rescan it in, but I'll send out a message on Google Classroom about the ones I've made mistakes on. I'm keeping track of them on a pizza box. Fun fact. (31) Find the equation of line in point-slope form that passes through negative 3, 5 and is parallel. So if it's parallel, all they're telling us the slope of our line our answer is going to be. So if this slope is 4 and it's parallel, the slope we're going to use is also 4. So once you know the slope and the point, if they want it in point-slope form, it's actually pretty easy. Y minus 5, y value, is equal to your slope times x minus negative 3. Again, make sure if you have minus and negative, please clean that up. Minus and negative is plus. Equation point-slope form, so that's good too. That passes through this ordered pair and is perpendicular. So now perpendicular is the opposite reciprocal of this. So the slope I'm going to use is, their slope is negative, so mine's positive, and instead of 2 over 3, it's 3 over 2. But again, once you know the slope and the point, now it should be easy. Y minus negative 4 is equal to 3 over 2 times x minus 10. So that's y plus 4 minus negative is equal to 3 over 2 times x minus 10. Cool. Number 33, find the slope, x-intercept, y-intercept for each line. So for the slope, you're going to use the negative a over b. So for this one, it's negative 3 over negative 9, which is positive 1/3. So the slope for this one is positive 1/3. Then the cover-up method, the x-intercept, we cover up our y. Remember, when you do the cover-up method, we want to keep the x to get the x-intercept. So that leaves, change my color so we can stay organized. That leaves 3x is equal to 18. If you divide both sides by 3, that means my x-intercept is 6. And my y-intercept, oh geez, what happened? Oh, scared me. You almost heard a grown man cry, which, I mean, I'm kind of a crier, so it's not super surprising, but probably uncomfortable. We're okay, though. So our x-intercept, or sorry, our y-intercept, we cover up our x. So we have negative 9y is equal to 18. So divide by negative 9. Now my pen is lagging a lot. 18 divided by negative 9 is negative 2. Same thing over here. Let's try to stick with the same colors. So we have negative a over b, which is negative 1 over 4. So that's your slope, negative 1 over 4. Then the cover-up method. For x-intercept, we cover up our y. So we have, well, it's already there. X is equal to negative 12. So that's your x-intercept. Then your y-intercept. Cover up your x. So we have 4y is equal to negative 12. There we go. It's coming up back to speed. Negative 12 over 4 is negative 3. So your y-intercept is negative 3. Cool. Just checking my answers to make sure that I didn't make any mistakes anywhere, because that's happened obviously a lot tonight. All right, moving on. Chapter 2 is a long chapter. So we also had the transformations. That said, there's not a ton of these on the test. And again, if you know your stuff, these should go pretty quickly. But if you don't know your stuff, these are very, very difficult, because again, it's kind of like, it's really hard to get partial credit on these. You either know how to do them, they're easy, or you have no idea how to do them, you have to guess. But again, the good news is multiple choice. So I added this in here to help you guys out a little bit if you didn't understand. Again, it's going to be multiple choice, so it'll be a little bit easier. But the graph to graph the right, the graph to the right is the transformation of parent function x to the third. Describe the transformation. So really, they're just saying, how does it move? So this went to the left, 1, 2, 3. So left, 3. Then down, 1, 2. Down, 2. So if you put y is equal to x plus 3 to the third minus 2, not minus 4. That's awesome, and you're absolutely right, and that's way more difficult. So if you can get to that point, that's even better. But on the final, there is a question where you just have to do it that way. So here's the other thing that I want to make sure you know. The graphs below are of different parent functions, are from different parent functions. They aren't parent functions, they're from parent functions. Which parent functions are they from? Put the name and the equation. Well, if you just go to your formula sheet, we have all those here. If it's shaped like U, it's a quadratic. Whoa, it's a quadratic and it's x squared. If it's shaped this way, it's a cubic, x to the third, square root. It's a V shape, it's an absolute value. So use that on your test. Again, I'm giving that to you for the final. Don't miss those. So this one is a square root. And I added that about the name and the equation. And the equation is square root of x. And again, I don't need the equation for this. I just need the equation of the parent function. This is absolute value. Y is equal to absolute value of x. This one is a little loop-de-loo, or a little curvy S-looking thing, which is a cubic. Which again, I know some of you guys don't know that, but that's on here. Cubic. That's y is equal to x to the third. And this last one, hopefully you guys all know, is quadratic. Can't spell it apparently, but that's okay. Y is equal to x squared. Again, I know I was a little bit more specific on this than I was on your practice review. But now, again, on the test, it's going to be a little bit more clear because it's going to be multiple choice. So if you thought, oh, I didn't know I was supposed to write the equation for the parent function, well, it's multiple choice, so it's going to be pretty obvious. Draw a quick sketch of each type of graph. So quadratic is a U shape. Square root is kind of like half of U on its side. Cubic is a little loop-de-loo, and absolute value is the V. Don't make that harder than it is either. Now, a lot of people asking me this. What's the vertex and the axis of symmetry? So the vertex, you just have to look at this graph here, and it's the corner, and what's that ordered pair? Go over 1, up 2. That's the vertex. The axis of symmetry is the line that goes through the vertex. It's a vertical line, so technically it's got to be x is equal to, but again, multiple choice, you're probably going to have that. But what's that line? Well, it's always the x value of your vertex. It's x is equal to 1. For each equation below, list the transformation. So this is to the left. Remember, if it's inside your parentheses or your absolute value or your square root, it kind of seems like it's opposite. So plus is actually to the left 3, 2 is down 2. That one makes more sense. Now this 1/2 is a vertical compression by a factor, that one's a long one, of 1/2. Remember, it's a stretch if it's bigger than 1. Since it's smaller than 1, it's a compression. And then up 3. This one is left 1 and a vertical stretch by factor of 3. By factor of 3. This one, and again, if you look, forgot that these are all in here. You can kind of, if this helps you at all, you can use that. These reflections, if you look, if it's outside the parentheses or the square or the absolute value, so there we go. If it's outside that stuff, that means it is across the x-axis. So you can use that. Reflect across x-axis. I do want to make sure I have that one correct because that is something that I would miss if I'm going too quickly. Nope, got it. Cool. Which brings us to the chapter 3 materials, which is the last materials we're going to do right now for this video. So part 3 coming soon. I know you guys are all on the edge of your seats. You guys are probably up at 12:20 right now, just waiting for this to come out. You're so eager. Hopefully it goes on Netflix.